River deltas are sinking faster than seas are rising, threatening hundreds of millions. The world's major river deltas, home to roughly 500 million people, including some of the planet's most vulnerable populations, are sinking at alarming rates, often outpacing the effects of global sea level rise. A new analysis of satellite data reveals that this subsidence poses a greater immediate risk to communities in these low-lying areas than climate change alone. The problem is not just rising oceans. It's the ground itself collapsing beneath millions of feet. The scale of the crisis: 10 megacities with populations exceeding 10 million are built on sinking deltas, including major hubs in Asia, Africa, and the Americas. Researchers led by Manuchaehar Shirzi at Virginia Tech examined 40 river deltas worldwide, including the Mekong, Mississippi, Amazon, Yangtze, and Nile, using high-precision satellite radar data collected between 2014 and 2023. The findings are stark. In over a third of each delta area, the land is sinking. In 38 out of 40 deltas, more than half the area is subsiding. Average subsidence exceeds sea level rise in 18 of 40 deltas. This means that for many people, the ground is sinking faster than the ocean is rising, making flooding and displacement far more likely. This is a critical distinction because it means localized action can make a difference. Why are deltas sinking? The primary driver is human activity. While global sea level rise occurs at about 4 millimeters per year, many deltas are sinking at rates exceeding this, some by double or more. The key factors include groundwater extraction. Pumping groundwater for agriculture, industry, and urban use compacts the underlying soil. This is the most significant contributor to subsidence in many areas. Sediment alteration. Dams, levees, and river engineering reduce the natural sediment flow that replenishes deltas, leading to erosion and sinking. Urban expansion. The sheer weight of cities on delta surfaces exacerbates the problem, increasing water demand and indirectly intensifying groundwater depletion. Thailand's Chao Phraya Delta, where Bangkok is located, is the most affected. It's sinking at 8 millimeters per year, with 94% of the area subsiding faster than 5 millimeters annually. The combined effect of sinking land and rising seas means Bangkok is experiencing relative sea level rise at 12.3 millimeters per year. Other cities facing rapid subsidence include Alexandria, Egypt, Jakarta, Indonesia, and Surabaya, Indonesia. The role of data centers and water demand. The report specifically points to water-intensive facilities like data centers as exacerbating the issue. These centers require vast amounts of water for cooling, which often comes from local groundwater supplies. In already vulnerable regions, such as the Mekong Delta, increased water demand accelerates sinking land, undermines drainage systems, and shortens the lifespan of infrastructure. Policy implications and what can be done. Shirzi argues that policymakers are too focused on climate-driven sea level rise and risks, misdirecting adaptation efforts. Unlike global sea level rise, human-driven subsidence is often locally addressable through groundwater regulation, strict limits on groundwater extraction, managed aquifer recharge, replenishing depleted aquifers, sediment management, restoring natural sediment flow to deltas. It's a mistake to only focus on climate change, Shirzi says. Human-driven subsidence is often locally addressable if we take the right steps. The data makes it clear. Failing to address localized subsidence alongside global sea level rise will leave hundreds of millions at increased risk of catastrophic flooding and displacement. The situation demands immediate, targeted action to protect these critical ecosystems and the communities that depend on them.